Every great innovation starts small. A strong foundation, careful design, growth that follows when the roots are proven. With JANUS, we followed the same path. Like the greatest feats of engineering, JANUS began small, tested, refined, and built on principles that never changed. And just like those technologies we trust today, JANUS is scaling to meet a bigger future.
Since the very beginning, we faced skepticism, which is honestly not really unusual considering we've invented something that has never been seen before in the industry. It reminds me of a book that the inventor of JANUS had recommended to me, and one of the points from the author is that brick walls exist not to keep you out, but to see how badly you want something. With JANUS, we know there have been doubts, but we have tested, and every test we've conducted, we've passed with flying colors. We have proven that JANUS works. One of the questions that we've had is, how can a system built to handle 5 tons of wax a day grow to 75 tons? Well, we worked with world-renowned engineering firms to model, design, and confirm the scalability of the technology. Today, we are conditionally approved globally for McDonald's, and we're in stores in Argentina and Brazil.
The foundation is proven, the path is clear, and like every great innovation before it, JANUS is ready to be scaled. Every day, we rely on extraordinary feats of engineering. Bridges that span oceans, planes that cross continents, cruise ships weighing over 100,000 tons, and skyscrapers that reach towards the sky. All of these marvels began with nothing but doubts, and now look where we are today. Let me take a step back. How did you get here today? Perhaps you flew. Did you find out what type of plane you were on? Who the pilot was and what their credentials were? When was the last time that plane underwent a thorough maintenance? Or if that aircraft has encountered any technical difficulties? If you didn't fly, then what about the car you drove here in? When was the last time it was serviced? Can you recall if it's ever had a mechanical issue or if it's ever required emergency repairs? And if you think about it, when was the last time you even checked your tires or engine? You probably don't know the answers to these questions, and honestly, why would you? These technologies, whether it's the plane that takes you across the country or the car you trust to get you from point A to point B, have been tested, refined, and perfected to the point where we no longer need to question them. They've become an essential part of our everyday lives, operating seamlessly without us even thinking about it. But just because we trust them now doesn't mean they started that way. Every great engineering marvel we rely on today had to start small, be tested, and proven over time. Bridges are a perfect example of how humble beginnings can evolve into something world-changing. Imagine crossing streams on top of simple wooden planks. These basic structures did the job, but couldn't support heavy loads. The engineering principles of weight distribution and support were there, but materials like wood were limited. As we began using stronger materials like stone and iron, engineers built upon those same principles, creating stronger and more reliable structures. The Brooklyn Bridge, completed in 1867, was a monumental achievement. Engineers testing the bridge's strength even brought an elephant across it, demonstrating that these same principles, weight distribution, tension, and balance, could support an entire city's traffic. Today, bridges still rely on those same engineering fundamentals, but they are constructed with advanced materials and methods, allowing them to span vast distances and support massive traffic loads. The engineering may have evolved, but the core principles have not changed. And it wasn't just bridges. As we mastered how to move across rivers and seas, we also needed to move faster across land. The evolution of transportation followed the same path, starting with horses and carriages before giving way to automobiles. Before the automobile,
Horses were the primary mode of transportation. They were essential for moving people and goods, but they had limitations in speed and efficiency. The concept of replacing horses with something faster and more reliable was born out of a need for progress. The automobile, like the horse-drawn carriage before it, followed basic principles of mechanical movement and transport. Early cars, developed by inventors like Carl Benz, used the same basic principles of power, friction, and propulsion that had been explored with steam engines. The breakthrough came with Henry Ford's Model T in 1908, which didn't change the fundamentals of the engine, but applied them on a mass scale, making cars affordable and practical for everyday people. As cars evolved, so did the technology. Innovations like automatic transmission, power steering, and air conditioning made cars more comfortable and easier to drive. Safety features, including seatbelts and airbags, were introduced, making cars not only more convenient, but safer. Today, cars are integral to our daily lives, evolving into smarter, more efficient, and sustainable machines. With electric cars, hybrid engines, and self-driving technology emerging, the future of cars promises even more innovation, making them smarter, greener, and more reliable than ever before. But speed on land wasn't enough. We looked upward, dreaming of taking to the skies, overcoming gravity itself. The dream of flight, once seen as impossible, became a reality built on sound engineering principles. Flying began with the simple principle of overcoming gravity. The Wright brothers' first flight in 1903, lasting just 12 seconds, proved that the basic principles of lift, thrust, and drag worked. While their plane was basic, the core engineering behind it, the understanding of aerodynamics and propulsion, laid the foundation for modern aviation. Today, the aircraft we trust to carry us across continents still rely on those same basic principles of flight: lift, thrust, and control. The technology has become more advanced, but the core engineering has not changed. Airplanes today are safer, faster, and more efficient, but the basic principles of aerodynamics that powered the Wright brothers' flight are still what keep us in the air. And once we mastered flight, we set our sights even higher, not just flying through the sky, but building into it, leading us to the next incredible leap in engineering: the skyscraper. Skyscrapers once seemed like an impossible dream. The idea of constructing towering steel and glass structures that reached into the sky was met with skepticism. Early skyscrapers, like the home insurance building in Chicago, stood at just 10 stories, a height that was once unimaginable. Engineers and architects struggled with how to support the massive weight of these structures. It wasn't until the development of the steel frame in the late 19th century that building tall became possible. As the 20th century progressed, skyscrapers began to soar. Iconic buildings like the Chrysler Building and the Empire State Building pushed the limits of height and innovation. These skyscrapers were engineered to sway slightly with the wind, a vital design feature that ensures stability even in the face of high winds and storms. Thanks to deep foundations that anchor the building securely, the structure can flex without compromising safety. Today, skyscrapers are not just buildings. They are feats of engineering that dominate city skylines. They represent the culmination of innovation, blending form and function to create structures that reach unimaginable heights, proving that with the right foundation, there are no limits to what we can achieve. But while we built towards the heavens, we also conquered the seas. The evolution of ships from simple vessels to floating cities is another example of how proven engineering principles can create something extraordinary. Cruise ships began as small, basic boats used for simple transport across the sea. These early vessels were basic and functional, built for transportation rather than luxury or leisure. But over time, the idea of using ships for leisure travel began to take hold. By the mid-20th century, ocean liners like the Queen Mary and the SS United States emerged, offering passengers comfort, elegance, and speed. The real transformation began in the 1980s, when the modern cruise ship was born. Designed to be much more than just a way to cross the ocean, these ships became floating cities, complete with restaurants, theaters, pools, shopping malls, and even amusement parks. They were no longer just about transportation, they were about the journey itself. The concept of a vacation on the water with luxury and entertainment on board became a reality. Today, cruise ships are marvels of engineering. They are designed to handle the forces of the sea, from ocean swells to storms, while maintaining stability and comfort. These floating cities are not just ships. They are a world of experiences, offering everything from fine dining to live performances, all while sailing across the ocean. The same pattern repeats throughout history. Start with the sound foundation, test it, refine it, and scale it. That's exactly the philosophy behind JANUS. Just like the engineering marvels we've seen, bridges that span vast oceans, planes that cross continents, and skyscrapers that defy gravity, JANUS began with a proven design. Think back to the Wright brothers' first 12-second flight, a moment that proved the principles of lift, thrust, and control. Fast forward to today, and the Boeing 777X carries passengers across continents, powered by those same principles, refined and scaled to new heights. Or consider the Brooklyn Bridge, where engineers proved its strength by marching an elephant across it, a bold demonstration of confidence in their design. That same spirit of testing, refining, and proving underpins every decision we've made with JANUS. We started with a solid core design, made sure it worked, and only then did we scale. And just as cruise ships evolved from simple vessels to floating cities, JANUS is expanding, engineered for much greater capacity without changing the soundness of the original design. Scaling isn't a leap of faith. It's a logical step forward, one built on verified principles, proven performance, and unwavering commitment to reliability. With JANUS, you're not relying on untested innovation. You're building on trusted engineering, the same kind that has powered the world's most enduring technologies. This is more than growth. This is progress, building bigger, stronger, and smarter on a foundation designed to last.